Good morning, children. Saram. Children, today we are starting with the first chapter of organic chemistry, that is haloalkanes and haloarenes. Now, children, as you all are already familiar with the word haloalkane and haloarene, so we can start with the chapter directly. I'll just give you a small introduction. You all know the meaning of the word halo. Halo means the halogens like fluorine is there, chlorine is there, bromine is there, iodine is there, astatine is also there, but its compounds we are not going to study. And alkanes, as you already know, are the hydrocarbons like methane, CH4, ethane, C2H6, propane, C3H8, butane, pentane, hexane, and so on. So, what are haloalkanes? Haloalkanes are the compounds which are formed by replacement of one of the hydrogen from an alkane by any of the halogen. An example of a haloalkane is CH3Cl. Now children, you have to remember whenever we are writing the name of such a compound, we have to write down the name of the halogen first, and after that we have to write down the alkane. Now children, you have to remember this thing also, that halogens are not actually functional group. They are not functional groups, so their name is not written after the name of the alkane. The name is written in front of the name of the alkane because they are substituents. Now haloarenes are an aromatic hydrocarbon in which any of the hydrogen is replaced by a halogen. X means any of the halogen, fluorine, chlorine, bromine, iodine, any halogen. Now children, why are we studying haloalkanes and haloarenes? Because these haloalkanes and haloarenes have got great importance in our day-to-day life. How? See, one of a very important hormone is there in our body, that is thyroxine, secreted from the thyroid gland. It is an iodine containing hormone. Iodine is a halogen, and the deficiency of this iodine in the diet causes the disease goiter. Similarly, an important medicine, that is chloramphenicol, it is produced by the soil microorganism to treat typhoid fever, and this medicine also contains chlorine. Synthetic halogen compounds like chloroquine is used in the treatment of malaria. So, you all got to know that many of the halogens containing alkanes or arenes are very important for our body and for many other things that we'll study later on in the chapter. Now children, coming to the classification of haloalkanes and haloarenes. Now children, haloalkanes can be monohaloalkanes, dihaloalkanes or trihaloalkanes. Mono means when one halogen is present. Dihaloalkanes means two halogens are present, and trihaloalkanes means three halogens are present. Similarly, in case of arenes also, monohaloarene, dihaloarene and trihaloarene, depending upon the number of arenes present on the number of halogens present on the arenes. Now children, these monohalo compounds, they can further be classified depending upon the hybridization of the carbon containing the halogen. Now children, another classification of haloalkanes can be primary, secondary and tertiary haloalkane. Now you have to remember that when the carbon which is containing the halogen is further attached to one more alkyl group, then it is a primary haloalkane. If the carbon containing halogen is further attached to two other carbons or alkyl groups, it is called secondary haloalkane. And tertiary means the carbon containing halogen is further attached to three more carbon atom is called your tertiary haloalkane. Now next is allylic halides. What are allylic halides? Allylic halides are those in which the carbon containing halogen is further attached to that carbon which is having a double bond. Here you all can see the carbon which is containing the halogen is connected to that carbon which is having a double bond. So such halides are called the allylic halides. Similar example is another. This is the other example in which the carbon which is connected to the halogen is connected to that carbon which is sp2 hybridized. Next is benzylic halides. Benzylic halides means the carbon containing halogen is further attached to that carbon which is connected to the benzene ring. Such halides are called benzylic halides. Children, we are studying these classification, but actually CBSE, in the present year syllabus of CBSE, this classification is not included. We cannot say whether something will be asked or not, but still for your knowledge we are studying. These are the now next are vinylic halides. Vinylic halide means the carbon containing halogen itself is a sp2 hybridized carbon, that is having a double bond. And aryl halides are actually your haloarenes. Now nomenclature you already know, like the first example I'm taking for nomenclature is a chain of 3 carbon atoms and to that one halogen is attached. Now while writing the IUPAC name, you have to remember, start the numbering from that side from which the carbon containing halogen gets the least possible number. So this will be carbon number 1, carbon number 2 and carbon number 3. Now the name of the compound, as I told you, halogens are not functional group, they are substituents, so written in front. On first carbon Br is attached, so it will be 1-bromo and the name of the main chain is propane, so it will be 1-bromo propane. Similarly, this will be 2-chloropropane. And when the halogen is attached to the second carbon, in common nomenclature it can be written as isopropyl alcohol. Third is, this is a haloarene, that is bromobenzene. Bromine attached to benzene is bromobenzene. Now here you can start numbering from any of the carbon which is attached to bromine. It will be 1,3-dibromobenzene. Commonly they are present at meta position with respect to each other, so it will be meta-dibromobenzene. Similarly, in this compound again we have to start the numbering from that side from which the halogen containing carbon gets the least possible number. So it will be carbon number 1, 2, 3. Now on carbon number 1, one substituent is there, that is chloro. On carbon number 2, two substituents are there, that is methyl. Now methyl starts with M, chloro starts with C. So in alphabetic order we will write 1-chloro, 2,2-dimethyl propane. It is 1-chloro, 2,2-dimethyl propane is the name of the compound. Now children, Other examples for name you all can see in the given table. You have learned in 10th standard also, 11th standard also, you have learned these names. So we are not going in very much detail. If I'll show you the PDF for the syllabus given by CBSE for this year in haloalkanes and haloarenes, the topics that we have to study is nomenclature, nature of CX bond. Methods of preparation are not there, as you all can see. After nature of CX bond, we have to study the physical and chemical properties, and then optical rotation of and mechanism of substituents. So nomenclature we have done. Other examples also we can discuss, like for example the compound, this first compound on this chlorine is attached on the second carbon, so will be 2-chlorobutane. Similarly, this compound, if you extend this and write, this is carbon attached to CH2 and it is attached to Br, and this carbon is further attached to 3CH3 group. Now you can name it. It will be again the same example that we have taken there. It will be 1-bromo 2,2-dimethyl butane. Sorry, not butane, it will be propane. 3 carbon atoms are there. Similarly, this compound, the fourth one, this one will be 1-chloroethene. And here, this is an important example, this one. See here, you have to remember while naming such compounds, you have to give preference to double bond. So numbering will start from that side where double bond is getting the least possible number. So this will be carbon number 1, carbon number 2, carbon number 3. It will be 3-bromo prop 1-ene. This 3-bromo prop 1-ene, or simply you can write it as propene. Now coming to the nature of CX bond. Now children, CX bond means the bond between the carbon and the halogen. Now as you all know, halogens are more electronegative than carbon. So when the bond between the carbon and the halogen is formed, then the bond is a polar bond. Polar bond means when this is carbon, this is halogen. The bond is polar because the electron pair shifts more towards the halogen, being more electronegative. Halogen attains a partial negative charge and carbon attains a partial positive charge. So due to this, the halogen carbon bond is slightly polar. Now we all know that when we go down the group from fluorine, chlorine, bromine, iodine, then the size of atom increases. Now the smallest one is fluorine and the biggest one is iodine atom. It is the largest. So because of this, the bond length between carbon and fluorine is smallest, and that between carbon and iodine is more. Now some typical bond lengths are given here. Now you all can see in this table the bond length of carbon fluorine bond is 139 pm. From carbon chlorine bond, if we move, it increases slightly. Carbon bromine bond is furthermore longer, and carbon iodine bond is 214 pm. So down the group, the size of atom is increasing, bond length also is increasing, and the bond enthalpy decreases. That means the bond between carbon and fluorine will be stronger compared to carbon and iodine. Now children, The next topic given in your work is methods of preparation, but as I have shown you the syllabus just now, the syllabus as I have shown you, in this syllabus this is for the present year 2020-21. Here, after nature of CX bond, the next topic given is physical and chemical properties. That means your methods of preparation are not there in the syllabus. So, we will not be doing the methods of preparation. We are directly moving towards the physical and chemical properties. Now children, whenever we are studying organic this year, in physical properties we have to study only two things. The first one is melting and boiling points, and the second one is solubility. Two important points we have to study. Now starting with the melting and boiling points. Now children, the lower members like methyl, ethyl, such iodides or halogens containing 1, 2 or 3 carbon atoms, they are generally gaseous at room temperature. The higher members are liquid and still higher are solids. That means with the increase in length of the carbon chain, as the molecular mass is increasing, so they are converting towards the solid. Now, as we all know that the bond between carbon and halogen is polar, so due to the polar bond, the force of interaction also increases. So, if we compare a simple hydrocarbon with a haloalkane, then because of polar bond, the interaction is more, so these compounds will have stronger intermolecular interaction and will have higher boiling points also. Now, if we compare the boiling points of isomeric haloalkanes, like a straight chain haloalkane we are having, this 4 carbon containing straight chain haloalkane, 4 carbon containing branch chain and more branched. Now, if we compare the boiling points of these compounds, then with the increase in branching, the boiling point also increases. In general, I am talking, do not see the values. In general, with the increase in branching, with the increase in branching, the boiling point decreases. Why it is decreasing? If we compare one chain and two chain of a straight chain haloalkane, then the surface area is more. Van der Waals forces of attractions are also more. So, boiling point will be more. But if we compare the one which is branched, it will have lesser surface area. So, Van der Waals forces of attraction will also be less. Now, if we see the one which is furthermore branched, the surface area reduces and the Van der Waals forces of attraction also reduces. So, with the increase in branching, boiling point decreases. This is not the only case for haloalkanes. It is for all the compounds. With the increase in branching, boiling point always decreases because surface area is decreasing. Now, if we compare the boiling points of isomeric dihalobenzenes, then we'll see that the para isomer will always have highest melting point or boiling point. It is because of the symmetrical reason. It can fit easily into the crystal lattice. We see the boiling points of 1,2-dichlorobenzene, 1,3-dichlorobenzene, 1,4-dichlorobenzene. 1,2 is ortho-dichlorobenzene, 1,3 is metadichlorobenzene, and this 1,4 is paradichlorobenzene. Here, para isomer in general will have higher boiling point because it fits easily into the crystal lattice. This is not the only example. Do not see the values. Now coming to the solubility. Now children, haloalkanes are very slightly soluble in water. Why they are very slightly soluble in water? It is because more energy is required to overcome the interaction which is there between the haloalkane molecule and to break the hydrogen bonds between water. Whereas when the bond between or interaction between water and haloalkane molecule is formed, very less energy is released. But haloalkanes dissolve in organic solvent to a very better extent. They can easily dissolve in the organic solvent and have the new interactions which are formed between the organic solvent and the haloalkanes. They are having much more strength compared to the one which are broken between the haloalkane molecules. So there's an in-text question. We can discuss this here also. Arrange the each set of compounds in the order of increasing boiling point. Now, as I have already told you, with the increase in branching, boiling point decreases. If we see the compound, it is bromomethane, that is CH3Br, one carbon only. Bromoform, that is one carbon and 3 Br. And chloromethane is CH3Cl. And dibromomethane, this is methane and 2 Br are there. And 2 hydrogens will also be there. Now if we compare, we can easily compare on the basis of molecular mass. You can arrange them in the order of increasing molecular mass. You will get the order of boiling point. And for this branching, you have to take the you have to consider the concept of branching. 1 chloropropane is a straight chain compound. Isopropyl chloride is branch chain. 1 chlorobutane, as 4 carbon atoms are there, molecular mass will be higher, so boiling point will also be higher. So this will be having highest boiling point, this will be having slightly lower, and this will be having the least boiling point. Now children, we'll wind up for today with this match, and in the next presentation I'll be starting with the chemical properties of haloalkanes and haloarenes. So, Sai Ram and thank you for today.